Okay, in this video, I'd like to recap the video that I asked you to watch on Friday and the worksheet that went along with it, and we'll talk about how we can utilize that in today's assignment. On the video on Friday, um, I walked you through combining complex numbers, either by adding, subtracting, or multiplying, but then also by dividing, and this was the new part. Now, with adding and subtracting, we simply combine like terms or like components. And for multiplying, we distribute either one at a time or double distribute in a FOILing process if necessary. And the big takeaway here is that anytime that we encounter an I squared, we need to change or substitute that with -1. And so in the video, I walked you through a process of that several times. However, hopefully you caught my mistake here. This was unintentional, but it was a mistake nonetheless. After performing the double distribution or the FOILing process here, everything was fine up until this point, but I made a simple math error. 16 plus 25 is not 36, but instead 41. So we should see a final answer of 41 here, not 36. As far as the new stuff goes, something we haven't talked about yet in class are these things called complex conjugates. And we have to use them in order to complete the division process of complex numbers. So we simply multiply the numerator and denominator by the complex conjugate of the denominator. So we look at the denominator and decide what the complex conjugate is, and then we multiply the numerator and the denominator and simplify from there. So in this first example, we had a denominator of 3i. Well, 3i is the complex number 0 plus 3i. So the conjugate of that is not 0 plus 3i, but 0 minus 3i. And we perform that multiplication across the numerator and the denominator. So we essentially had two mini problems here, and we did all the math necessary to simplify. And when we get to this point where we have a fraction over a denominator, this denominator will always be a real number. But rather than leaving it as a single fraction with a single denominator, we can go ahead and split this apart into two. This 9 can divide the 36 and the 27i in this case. So we have a number written in complex form with a real component and an imaginary component. And what's more is that these numbers can be further simplified. 36 divided by 9 is 4, and 27 divided by 9 is 3. So now we really have a final answer that looks like our complex numbers. So hopefully that makes a little bit more sense. For the problems that are still confusing to you, please find the time to see me before school or after school. You can also come down during flex, and we can have a conversation one-on-one to hopefully help you understand the math just a little bit better. Now for today in class, I would like for you to complete the 10 problems on this worksheet. I'm also going to add 2 more at the end of this video. Now I'm going to walk through a handful of these, and I'll expect you to complete the others on your own, and we'll check the answers together when we see each other next in class. With the addition or subtraction of complex numbers, we would clear parentheses first and then combine like terms. So we have -i plus 2i in this case, which simplifies to just the number I. -1i plus 2i is positive I. For number 3, we'll do the same thing. We'll clear our parentheses, which in this case does not require any extra work. And now we'll combine like terms. -1 has nothing to combine with, but -2i plus 5i is a positive 3i. So we'll leave that as our final answer. For number 5, in order to multiply these two complex numbers together, we need to go through the FOILing process, and we need to distribute twice. So 4 times negative 6 is negative 24. 4 times negative 3i is negative 12i. 3i times negative 6 is negative 18i, and then 3i times negative 3i is negative 9i squared. I'll go ahead and combine like terms. Negative 12i minus 18i is minus 30i. And also I need to change this I squared to the number negative 1. And no changes to the negative 24 minus 30i, but negative 9 times negative 1 is positive 9. And negative 24 plus 9 is negative 15. By the time we get to the end, we have an answer that does look like a complex number with a real number component and an imaginary number component. With a problem like number 7, we should probably clear the parentheses and then combine like terms. So 8 plus 2i doesn't change, but this minus sign that's in front of this group technically distributes into both, much like a negative 1 when multiplied would. So we have minus 6 plus 3i. Now without any parentheses, we can combine our like terms. 8 and negative 6 combine to make 2, and 2i with 3i combine to make 5i. It is not 5i squared, remember, it's just simply 5i. Now number 9 and 10, these are pretty challenging, and I would probably label them bonus level difficulty. But if you go through the same process as before, you'll notice that the solutions can be obtained in very much the same fashion. The only trouble with number 9 here is that we've got a lot of distributing going on. This negative 6 distributes, but with distribution, it stops after the first set of parentheses. So we have negative 12i. Now I notice a lot of you, when you're doing your work in my class, don't appear to keep your math very well organized, or you try to do several steps at one time and ultimately get yourself messed up. What I would really strongly encourage you doing is just one step at a time, and don't be afraid to rewrite your work from row to row. It may seem tedious and boring at first, but I assure you it will, it'll help you out in the long run, keeping your work organized. Now, on the second line, we have a negative 12i that has to distribute, and the distribution stops after the first set of parentheses, so it only goes to these two numbers. We have negative 12i times 6, which is negative 72i, and negative 12i times another 3i, which is negative 36i squared. We'll fix that I squared in just a second. So I'm just copying down the remaining elements. I'm not making any changes yet, just making a copy of them. But now that we don't have any more distributions to make, no more foiling or anything like that, I'll go ahead and change this I squared to negative 1, and I'll clear these parentheses. So negative 72i minus 36 times negative 1 plus negative 6 plus negative 4i. That would be the same as minus 6 minus 4i plus 1 minus 7i, and negative 72i plus 36. That's the only change I'm making in this row. I'm changing the negative 36 times negative 1 to positive 36. Everything else is just copied down one more time. And now I can combine my like terms. I have 36 minus 6 plus 1, which appears to be 31, and negative 72i minus 4i minus 7i, which adds to negative 83i. So all of our like terms have combined. There's no I squared component left over, so I would leave this as our final answer. Now this worksheet generator did not put any division problems into the set, so I'd like to add 2 now. Now I'll work through number 11 and I'll ask that you complete number 12 on your own. Well, here again from the video on Friday of last week, we need to multiply both the numerator and the denominator by the complex conjugate. Instead of multiplying by 6 minus 7i, we'll multiply by 6 plus 7i in both the numerator and the denominator of the fraction. It's this trick that's going to eliminate the complex number in the denominator of this fraction. Now here again, this can be a bit tedious, but we simply have to FOIL both the numerator and the denominators separately. So I'm going to go ahead and tackle this numerator first. 8 times 6 is 48. 8 times 7i is 56. 2 times 6 is 12, so that's 12i, and 2i times 7i is 14i squared. So there's the numerator, and the denominator, 6 times 6 is 36. 6 times 7i is 42i. Negative 7 times 6 is negative 42i. We'll always see these two cancel if you're multiplying by complex conjugates. That's part of the reason why we do this. And now finally, negative 7 times positive 7 is negative 49i squared. So let's keep working on this. In the numerator, I'll change the I squared to negative 1. So we have 48 plus 56. I tell you what, we can go ahead and combine like terms at the same time as well. And 56i and 12i is 68i plus 14 times negative 1. In the denominator, we have 36 minus 49 times negative 1, because these two had already canceled and disappeared. So we have 48 plus 68i minus 14 over 36 plus 49. And finally, 48 minus 14 is 34 plus 68i. And 36 and 49 makes 85. That's okay as a final answer, but the better final answer would look something like this. 34 over 85 and 68i over 85. Although I think more frequently we would see it written this way, 68 over 85i. Now we have a real number component and imaginary number component, and altogether our final answer is a complex number. So I had intended for you to work on this worksheet in class using the video notes as a guide from last week, and then asking me or a neighbor in class for help. I do want to continue with that process, but obviously we couldn't do so with me not being in the building today. So thanks for your cooperation, and thanks for watching. Spend the rest of the time, please, in this class period finishing the even numbers from the handout. If there were no handouts available to you, you can find a blank copy on Schoology. Make sure you check out day 58.